Hello friends, in this video we will talk about springs. Okay, not a new word for you. We have learned one such word previously and that was string. What that word was? That was string. In physics, string means something which is massless, whose length will not change when the forces are applied. And what are these strings used for? They are basically used to transfer the force of tension from one point to other point. This is about spring. What is a spring? Spring is basically a helical shaped body, okay, and it provides us with three different types of force. First, the force of compression, the force of elongation, and the force of twist. Okay, Gabbar is back, right? So, spring provides us with these type of forces: compression, elongation, and twist. Right? We are not interested in the twisting of the springs now, because for that purpose some different kind of springs will be used, and that will be discussed in the later chapters. Here our spring can only compress and it can only elongate. Right? Why are we studying springs? Why do we study springs in physics? Because it applies some kind of force. Suppose if I am having simple kind of spring. Now spring can be of very different types. This can be like this. This is known as simple helical spring. The springs can be like this. Okay, the springs that are used in the remote controls just behind the dry cell. Okay, then there can be flat springs also, like 1, 2, 3 and 4 strips of metals that are bonded together. Where are these used? These are used in the chassis of very heavy vehicles. Alright. Now coming to the force that is generated in the springs. That force is given by Hooke's law. By Hooke's law. And what does Hooke's law says? Hooke's law says F is equals to minus kx, or F is proportional to x. How do we write Hooke's law? The statement of Hooke's law is force applied by a string or force applied on a string is directly proportional to displacement of the string. Right? Let us understand this with the help of this diagram. Here I was having a spring and I extended the spring. मैंने इस spring को इस तरह से खींच दिया. So the displacement of the spring was in this direction. Now what the spring will do? Spring will apply a force. It will apply a force and it will try to gain its original length. So the direction of that spring force will be opposite. Take a look at the above diagram. In this diagram, I am trying to compress the spring. ठीक है ना? X distance से मैंने इस spring को compress करने की कोशिश की. The spring, what the tendency of the spring will be? The force of the spring will try to maintain its original length, so it will apply a force in this direction. Okay, so in case of spring, force and displacement are always opposite to each other. That is why we put a negative sign in the vector form of Hooke's law. Right? F is the force of the spring, x is the displacement of the spring. Right? Spring की length 10 centimeter थी, आपने इसको खींच दिया. So what is the displacement? खींच के इसकी length को 11 centimeters कर दिया. What is the displacement? Displacement is 1 centimeter. एक स्प्रिंग थी, ठीक है, उसकी ओरिजिनल लेंथ थी 15 सेंटीमीटर, आपने इसको कंप्रेस करके 12 सेंटीमीटर्स बना दिया. सो व्हाट इज द कंप्रेशन ऑफ द स्प्रिंग और व्हाट इज द वैल्यू ऑफ डिस्प्लेसमेंट ऑफ द स्प्रिंग? पहले 15 था, अभी 12 हो गया, सो इट इज गोइंग टू बी 3. नाउ हुक्स लॉ सेज कि आप स्प्रिंग को जितना खींचोगे या जितना उसको दबाओगे उसमें उतना ही ज्यादा फोर्स डेवलप होता है. यानी इफ यू कंप्रेस इट बाय स्मॉल अमाउंट, small force will be generated. If you compress it by large amount, large force will be generated. Okay, that was about F and X. What is this K? K is known as the spring constant or it is also called the force constant of the spring. ये क्या होता है? Force constant of the spring depends on the type of spring. जैसे अगर आपका spring, imagine that spring that you have seen just below the bogies of a train. देखा है, हेलिकल शेप में होता है, it is very thick. Then come to the spring that you see in the shock absorbers of car. Same type of spring, थोड़ा सा thin होता है, उसका force constant कम है. Then compare it with the springs that you have seen in the shockers of a two-wheeler. Same type of spring, but वो थोड़ा सा और thin हो जाता है. That means force constant और कम हो गया. और लास्ट में उस spring के बारे में सोचो जो आपके टिचक टिचक वाले बॉल पेन में होता है. ठीक है? That is also the same spring, but it is very thin. That is again a spring and its force constant is still less. ठीक है, तो उसका जो मेकअप है, उसकी जो बनावट है, उस पे ये फोर्स कांस्टेंट डिपेंड करता है. उसकी लेंथ कितनी छोटी या बड़ी है, उस पे भी ये फोर्स कांस्टेंट ऑफ द स्प्रिंग डिपेंड करता है. ऑल राइट, x is displacement, k is the force constant, and negative sign in this is because of the fact that force and displacement are always opposite in the spring. Right? This was Hooke's law. Okay, a very century old law. Now, क्या स्प्रिंग के अंदर पोटेंशियल एनर्जी स्टोर होती है? डू स्प्रिंग स्टोर पोटेंशियल एनर्जी? ऑब्वियसली आंसर इज यस. यू हैव सीन in very old movies people were using rifles. Now they are using guns. Okay, gun and rifle, they are very much different from each other. Every time before you fire a rifle you have to load it with a bullet and then you have to cock that rifle. Okay, what is done in that cocking process? There is a spring inside it. That spring gets compressed and when you press the trigger, when you are pressing the trigger, तो वो spring खुल जाता है और उसमें जितना भी potential energy stored था, that is given to the bullet and the bullet fires off. All right, छोटे मोटे गेम आप भी स्प्रिंग से आपने भी खेले होंगे. Okay, so does spring stores potential energy? The answer is yes. When I compress it, whatever energy I am applying on this, that energy gets stored in the spring in the form of potential energy. Okay, कैसे पता? So when I release it, the entire potential energy is converted to kinetic energy. इसका मतलब उसने energy store किया. Can we calculate that energy stored in the spring? Obviously yes. That is the potential energy of a spring. Suppose I was having a spring and I compressed it or I elongated it by a distance xf. This was a normal length. मैंने उसकी लेंथ को खींच के या दबा के चेंज कर दिया. ठीक है, अभी आप देखो, अगर स्प्रिंग फोर्स कांस्टेंट फोर्स हुआ तो एल्जेब्रा पे जाएंगे, अगर ये वेरिएबल फोर्स हुआ तो कैलकुलस पे जाएंगे. आप इसके फोर्स की इक्वेशन देखो, लेकिन पहले आप जरा अपने दिमाग में ये सोचो कि वेरिएबल और कांस्टेंट कैसे डिसाइड करोगे? हाउ विल यू डिसाइड वेदर समथिंग इज कांस्टेंट और समथिंग इज वेरिएबल? आई टोल्ड यू twice and now I am telling you this third time. If any physical quantity depends on time or distance, then that thing is variable. If it does not depend upon position or time, distance or time पे depend नहीं करता, then it is constant. Now come to the force of the spring. F is proportional to x. That means it depends on displacement, and because it depends on displacement, it is variable. And for variable things, we have to use calculus method. So, in the first step, what I am doing, I am calculating the work done for very small displacement. छोटा सा displacement था, उसके लिए work done calculate किया. dw is equals to f dot dx. Angle between force and displacement is mutually opposite. 180 cos 180 is equals to minus. So this is minus f dot dx. Okay, now here put the value of x. F is equals to kx. Oh, यहां पे ज्यादातर बच्चों को एक डाउट आता है कि सर यहां पे आपने लिखा f is equals to minus kx, तो यहां पे आपने माइनस यूं उतारा, dx यहां पे उतारा, f की जगह kx क्यों लिखा, माइनस kx क्यों नहीं लिखा? See, you write f is equals to minus kx only in vector notation. In which notation? In vector notation. Here, when you multiplied this with this, You have now converted force into a scalar quantity. Scalar quantity में directions are meaningless. ये minus sign क्यों लिया था? Direction इन दोनों के opposite थे इसलिए. तो यहाँ पे when you put the value of f, it will not be minus kx, it will be simply kx. Expand this, what do you get? Minus kx dx. Okay, this is work done for a small displacement. But if suppose the displacement is large, displacement बड़ा है, शुरुआत में when you started there was no extension in the spring, x was equals to 0. अभी आपने इसको खींच दिया या इसको compress कर दिया and the change in the length of the spring is xf. Now the displacement of the spring is xf. How to calculate the total work done? Integrate करो, इसको integrate करो from the limit 0 to xf minus kx ds. Minus k comes outside. आप सोचो क्यों? Integration of x dot dx between 0 to xf. What is integration? X square by 2. So just put this value xf square by 2 minus 0 square by 2. This is ultimately going to give you 0. And what is this? Minus k xf square by 2. This is the work done. And what is potential energy? Potential energy is negative of work done. So when you write or when you convert work done into potential energy, ये negative sign आप ये यहाँ से हटा सकते हो. You can put minus sign, no problem with that, but you can remove it. Better to show with the removal of the negative sign. So what is the potential energy of the spring? It is kx square. यानी कि अगर एक स्प्रिंग है जिसका फोर्स कांस्टेंट है 10, कितना है? उसका फोर्स कांस्टेंट है 10. आपने उसको खींच दिया बाय ए डिस्टेंस ऑफ से 1 मीटर, कितना? या फिर 2 meters. You have extended the spring and by a length of 2 meters. So here 2 square will come and divided by 2. So what is this? This is 10 into 4 by 2. 2 cancels, 20 joules. Clear? So much easier is the calculation of potential energy of the spring.